The session is talking about an issue I think that has really been missed from a standardization perspective and a market perspective. And that's about how do we serve in-building users. And that's not just in-building users when they're at home or in the office. It could be anywhere they're indoors. And I think there's a real opportunity, obviously, to understand the pivotal role that OpenRoaming and WBA can take in terms of how do we serve indoor users moving forward. And I think if we look back the last decade, we've often talked about Wi-Fi offload. And offload is maybe a disparaging term where somehow Wi-Fi is less performant than cellular, where it's the main service. What I hope that maybe in 5 years' time, when we're seeing the launch of 6G, that we no longer talk about Wi-Fi offload. We talk about in-building wireless, which by default is Wi-Fi. And we are a core part of the overall ecosystem. So let's make a start in terms of where do we start? Let's start with the ITU, the International Telecoms Union. I'm sure most people in this room recognize that it's the ITU that sets the requirements for what is 5G and 6G and not 3GPP. Well, back in November last year, the ITU published their report M2160, which talks about the use cases for 6G. And if you recall, the ITU had defined the pyramid for 5G, the pyramid of use cases which were enhanced mobile broadband, massive machine type communications, and ultra reliable and low latency communications. We had a pyramid of 5G. Well, in 6G, we've gone from a pyramid to a hexagon. And so we've added 3 significant new use cases, and shown here on the left. And we've got new use case of integrated sensing. We've got a new use case of integrated AI. After all, AI is du jour, isn't it? And everything needs to come with a sprinkle of AI. But we want to focus on the last one, which is ubiquitous connectivity. And so what does ITU say about ubiquitous connectivity? You can see the quote here. IMT 2030, which is their tag for 6G. So 6G is expected to further extend into sparsely populated areas and maintain the consistency of user experience between different locations, including deep indoor coverage. Rather amazing that this is the first time that we call out a requirement for consistency of experience. So no longer focusing on those sort of peak marketing speeds and about recognizing that users care about consistency of experience rather than peak download speeds. And so we want consistency of experience from rural through to suburban, urban, and indoors. And why is indoors important? Well, if we look at data from Ericsson in their mobility report, they report that users, smartphone users, spend 90% of their time indoors, and they consume 80% of their smartphone data when indoors. So clearly, when we're looking at consistency of service, we want to bring in consistency of service as we move from the outdoor environment towards the indoor environment. So there's a recognition that we have a problem to solve here, that there is an increasing gap between the experience that we get in the outdoor environment. And in the outdoor environment, we may be on higher frequencies with wider channel bandwidths and massive MIMO capabilities, where we really have the best experience we get on the mobile network. And we contrast the outdoor experience with the experience that we face indoors. And the challenges of delivering indoor service is both technical problems and business problems. So from a technical issue, we know that buildings are becoming more thermally efficient. There's lots of investment into buildings to stop heat radiation, either getting into the building, as we'll experience, I guess, this afternoon, or getting heat radiation out of the building. And we do that by adding foil-backed insulation to the walls and dielectric coatings to the windows. And those same techniques that are designed to block heat radiation getting into and out of the building are just as effective at blocking radio wave propagation, radiation coming into and out of the building. And that may mean that in a typical residential building, you may have 99% of the energy failing to get into the building because of the radiation barriers. In an efficient office, it could be 99.9% of the energy incident on the outside of the building doesn't get into the building itself. So clearly we've got a technical issue, but we also have a business issue. The business case for indoors is challenging. And we see now that really the focus on indoors is taking a back seat compared to coverage requirements for outdoor 5G coverage. And we know that serving indoor users and the indoor business case is challenging. MNOs are CapEx constrained. And so MNOs are now frequently looking to neutral hosts to help in serving their in-building use cases. And so neutral host is interesting because a neutral host, a building owner can have a single relationship with a neutral host who can then provide coverage for all users within a building, irrespective of carrier affiliation. And the neutral host now doesn't necessarily have to charge the MNO for that service, but will frequently be charging the building owner on a CapEx or OpEx basis. But the business cases are still developing from a maturity perspective. But just to highlight, we have this challenge from indoor and outdoor experiences. So before we get to indoors, let's talk about outdoors. And some interesting data. So back from the Ericsson Mobility Report again, the headline figure from the recent Ericsson Mobility Report was that mobile data was growing at a compound annual growth rate of 21%. But dig into the figures and you find, rather surprisingly, that Ericsson is reporting that 1/4 of all the mobile data supported on the networks globally is associated with fixed wireless access. So it's not associated with these, it's associated with a broadband proposition. So what this chart does is removes the fixed wireless access and reperforms those calculations. And so when we remove the fixed wireless access component from the Ericsson data, we find that the smartphone data is only growing at 11% compound annual growth rate. And we can compare that with, well, what's happening in the broader market from a fixed perspective. How is fixed broadband growing? And we can overlay that data there you see in blue. And from a fixed broadband perspective, fixed broadband is typically dimensioned about 60 times that of a mobile broadband subscription. If you consume 10 gigabytes a month on your mobile subscription, it's likely that you may be consuming 600 gigabytes a month on your fixed subscription. So we should expect the growth rates to be very different because one is serving 600 times the traffic. When we look and compare the red line, which is mobile data, landing at 11%, and we look at the worldwide growth in fixed broadband, we see, surprisingly, back in 2024, they both converged at 11% compound average growth rate. So even though fixed mobile is supporting 60 times the traffic, it's now growing at the same rate as smartphone data on these devices. And so what we're saying is because those outdoor networks are only growing at 11% for supporting 1/60th of the traffic, it's going to be extremely unlikely that those outdoor-based services will be able to serve the needs of the indoor users. Even if we can solve the building penetration loss, we're not seeing the growth in capacity on those networks to be able to serve all indoor users. So where does that leave the indoor user? This is me. So if you see here, I'm on LTE at home. I'm on LTE band 20. So band 20 is 800 megahertz. It's digital dividend. It's frequencies freed up from turning off analog TV. It's not very wide channels. I'm thankful that Vodafone have got 10 megahertz of 800 megahertz of band 20. If I was on a different carrier, I'd only have 5 megahertz in this digital dividend band. And so you can see that's where I am on band 20 with 10 megahertz. You can see my reference power, neg 112. Right, so anything above negative 100 dBs is okay. Anything above negative 70 is really decent. I'm here at negative 112. I'm at the edge of the cell, sat in my home. What does that mean? It means that the experience I get is, you can see 7 megabits peak download, 1 megabit upload. I'm stuck here on a sub 1 gigahertz channel. And when you look at the quotes here from the GSM Association, so this is the trade body for the mobile operators, they absolutely call out that sub 1 gigahertz spectrum is essential to provide those indoor coverage. So they're saying, absolutely right, to get into the building, I need lower frequencies, and is then essential to provide those in-building services. But equally, second quote from GSMA is that the performance you get from sub 1 gigahertz is lower than the performance you get from the higher frequencies. Okay, when we look at the share of sub 1 gigahertz is 18%, but they only deliver you a 7% capacity uplift because you can't operate on these high order MIMO systems. So those indoor users are stranded on sub 1 gigahertz low order MIMO. Those outdoor users are on higher frequency, wider channels, higher order MIMO, and so we're seeing this disparity, this gap in service between the outdoor users and the indoor users. And so what is the result? I think I was particularly surprised to see the OpenSignal report on the US smartphone adoption. Not that the OpenSignal report says that 90% of US users use Wi-Fi when at home, so they're connected to Wi-Fi for 90% of the time when at home. That wasn't the surprise. The real surprise was that OpenSignal was reporting that between 77 and 80% of the time when the users are outside their primary residence, they're using Wi-Fi. So highlighting the fact that in order to combat this performance gap between outdoors and indoors, even when away from home, OpenSignal is reporting that US subscribers are increasingly using Wi-Fi to fill the gap between outdoor and indoor service. So, in building, how do we best serve in building? It's about scale. It's about massive numbers. So this is the distribution of US commercial buildings by square footage. And you can see in red, we have the buildings over 100 square foot, 100,000 square foot. And we compare it with the other buildings below. So when we look at the uber large buildings, 130,000 buildings above 100,000 square foot. about 2% of all commercial buildings are these large buildings. Candidly, these were the ones that have been the focus on the distributed antenna systems, the DAS systems, typically price in at 100,000, 200,000 square foot. So conventional focus on cellular has been on the large buildings. And then when we look at the coverage we get from a 5G G node B, we can see that in some scenarios, we can plan a 5G small cell with a 30,000 square foot coverage. Contrast that with Wi-Fi. So vast difference with how you would plan a Wi-Fi network. And so we see it sort of makes sense that where is 5G focusing on? Well, if you look at 5G private networks, they focus on the strip mines, they focus on the ports and utilities where I really need to benefit from that large coverage area that we get with 5G. And equally from a building perspective, the focus on 5G is going to be on those larger buildings, just as it has been in the past. But that leaves a significant percentage of the market. In the US, 5 million buildings are below 100,000 square feet, 2/3 of all square footage. And so when we're looking about how to solve this in-building problem, we've got to think about solutions which scale up to the very largest of buildings, but also scale down and across the full spectrum of building types that we see in this commercial environment. So we need a solution that scales, but also from an engagement model, we need a way to scale. Now, candidly, on the early days of Passpoint, I would contend that what was limiting some of the scaling was the ability of the carriers' legal teams to scale to the number of engagements they have as it relates to Passpoint. And we were seeing that that was constraining the growth of Passpoint networks. And we saw then the introduction of the neutral hosts to try and scale Passpoint adoption. The same applies as it relates to all in buildings. And so we've got to look at approaches that allow us to scale the engagement models. So that could be a neutral host. It could be a vertical partner. So we see from an OpenRoaming perspective, we see partners focusing on retail, food and beverage retail, and are focusing on OpenRoaming in food and beverage retail and using their channel expertise in that particular vertical to drive OpenRoaming adoption in food and beverage retail. Or it could be a vendor and how a vendor's looking to scale the systems. And finally, obviously, from an in-building perspective, there will likely be some IT infrastructure already in building. Can we leverage that general IT partner in terms of how to scale in-building systems? So we need solutions which are able to scale across the engagement models down to the general IT partner level. And finally, in terms of the legal engagement, I guess we know lawyers are expensive and they don't scale. And so how we think about solving in building is we've got to look at how do we scale those legal engagements. Yes, we can do specific terms, legal terms with the largest of buildings, but we know for scale, we need something that scales from a legal engagement perspective. And so one approach is to look at a federation approach to define those terms. And obviously the work that WBA has done in terms of defining templated terms in order to scale the legal engagements around the federation. So in building is absolutely all about scale in terms of serving the different building types, but also in terms of the engagement models and the legal terms that we use. And so what is clear, I think, now is that OpenRoaming has proved that federations can help scale this market. I think it's interesting that can you recall maybe 10 years ago, WBA used to report the growth in passpoint network adoption. So every year in the WBA report, they would say, hey, we've gone from 50 passpoint networks to 80 passpoint networks. And they mapped the growth in those networks on a year basis on tens of networks. Well, it's interesting that WBA has shifted from how they report those to a crowdsourced model. And so Cisco was the one that developed the enhancements to the Wiggle crowdsourcing app, which allowed the crowdsourcing apps to record the Passpoint Roaming Consortium organizational identifiers, the RCOIs, which are used for open roaming automatic network selection. And so now what we see is that every 24 hours, WBA systems go and look at the crowdsourced data and see how many open roaming networks get reported, and then aggregate that information into the famous open roaming map that you see here. And so WBA gets a spreadsheet every day for how many networks have been discovered in the last 24 hours. And then it's interesting from a trials perspective that we had a report on tens of networks being reported. We also had WBA in the early days of open roaming saying, hey, we've got 30 trials of open roaming ongoing. Well, here is just one example of one 24-hour period. And we can see the spreadsheet has reported that 478 existing networks were crowdsourced, but now 158 new networks were identified in 24 hours. And this isn't an outlier. Yesterday morning, we got the email saying that 94 new networks had been identified in the last 24 hours. Sunday morning, 226 networks had been identified. So we're seeing a shift when we're seeing hundreds of new networks come online. And so it's quite clear that the manual processes that WBA had in the past couldn't scale, but obviously we're showing now how federations can really scale. And so we see now regulators getting interested in mapping indoor coverage. Mapping indoor coverage is challenging. We can do our coverage map on outdoors, but how do we plan and predict indoor coverage? And the idea here, from a Cisco perspective, is why don't you ask your Wi-Fi network about indoor cellular coverage? We're particularly proud of our engagement that we have with our client device ecosystems. So that could be Samsung, Apple, and Intel in terms of how they communicate with the Wi-Fi network. When those devices attach to the Wi-Fi network, they send an encrypted action frame, which tells you about their platform and their operating system. If it's Intel, they will tell you if they're plugged into the power outlet. If they're Samsung, they'll tell you about their carrier build. But they also tell you about their beacon table, how they see the Wi-Fi network, how an access device sees, so how an access point sees a device is often very different from how a device sees the network. And we get information about why they leave. Did they leave because of a better RSSI, a better AP? Did someone disable the Wi-Fi network? But interesting from a Samsung perspective, we get how does the client see the cellular network? So what does that look like? We can then integrate the cellular reports into our indoor mapping solutions. So remember, we got an encrypted action frame saying, hey, I'm a Samsung platform. We can then send a request to the Samsung device to send me your cellular information using a vendor-enhanced 11 MBO request to the client, and a bit of CLI here about how you would do that. And so here we can see the Samsung device is saying, hey, I'm on 4G and I've got moderate signal strength. And we can then integrate that into our mapping solutions. And so here we've got a link to GitHub, which shows how to perform that. So when we look at that and how can we use that information, we can see that here we've got no cellular coverage. Here we've got 2G. Here we've got 3G, so limited multimedia, and here we've got full cellular data. Now, one way we could do this is we could look at how this impacts first responder services. So if we look at this particular map, it says that on this floor, 10% of floor area doesn't have any 2G service. If I was a public building, maybe the fire code that says I need to have 95% building coverage. But now we know the emergency services, the first responders, are moving to so-called next generation 911 service, NG 911, which requires multimedia. Interesting here, 33% of the floor area doesn't have multimedia access. Full service is only on 35% of that floor area. So very excited. Just last week, we had a new draft submitted to IATF about how do we integrate open roaming into those mission critical frameworks to be able to deliver first responder services throughout the floor using open roaming. Some of the work that's been driven with WBA. So what does that look like for 12 months of open roaming deployment at one healthcare business? And it's a large healthcare business over 2 campuses. You can see here, 250,000 devices, 3 million connections, over 1 petabyte of traffic, really showing how open roaming can drive adoption of in-building services in a healthcare environment. And just finishing in terms of the report from the customer, in terms of open roaming, they have reduced coverage complaints, lower support burden on their IT staff. They have happy visitors and patients. They have the clinical staff no longer spending time trying to getting people online. Users don't notice Wi-Fi. They seamlessly roam onto that and get a great data voice service, and they have a fast and cost-effective indoor coverage. So I know my time's up, but really the key takeaways, the in-building imperative. In-building connectivity now being explicitly called out in national infrastructure strategies. We see 6G IMT 2030, including ubiquitous connectivity requirements, including deep in-building coverage. We know there are challenges from a technology perspective and a business perspective about how to serve those indoor users. We think we need a different paradigm to scale beyond those 2% of buildings which have conventionally been the focus of cellular over 100,000 square feet. Open roaming has demonstrated how it can scale to from the largest buildings in terms of healthcare campuses to the smallest buildings in terms of food and beverage retail. We are having initial discussions with regulators about how we then drive the ability to serve emergency and mission critical use cases within open roaming. And an example we show, one of the largest healthcare establishments in the US deploying an alternative open roaming as an alternative to DAS. Open roaming is delivering fast and affordable indoor coverage while simultaneously lowering those support costs. So thank you for your time. I don't know if we've got any time for questions, but happy to take any. Thank you.
We have time for 1 or 2 questions. So anyone with any question? Sudhir? I can.
Thank you, Diego. Thank you, Mark. This is very fascinating, actually, with the example. So I see that the example you gave that 35% does not have any capability of cellular through multimedia services, right?
Right.
So specific question is that do your system or any thoughts about that can be used as a network selections within the building, right? As you roam, of course, open roaming can give the ability to roam between Wi-Fi, right?
Yes.
But now we are talking about that some part of the building cellular may work better, other part not, right?
Right.
And other part maybe Wi-Fi not.
Yes. Yeah. So good question. So Subir says, can we use that to roam? And so that's some of the work that we can do, but in the Samsung device, that we can try and trigger that roam. You see all the interworking, whereas today Samsung will be typically controlling that transition on their own. Could we send some information to try and trigger that transition? Not a BSSID transition, but obviously a transition from Wi-Fi to cellular, and I think we can do that. We obviously need to work cooperatively with those device ecosystems. But I think it's interesting. You know, the fire codes that says that I need 95% of voice coverage in a public building. If I'm doing a 9G, an NG 911 service, that's not going to be sufficient. I need data. And so this is the first time we see the ability to identify that we for 35% of the floor area, we don't have data coverage.
Thank you. I think that's very important, data.
Yeah, thanks.
Thank you. Any other question from anyone? Rolf?
Thank you, Mark, for the presentation. Interesting. On point. I had a question on the healthcare example that you mentioned, where they are migrating to open roaming. What was in place, to make sure that open roaming actually works in that healthcare environment? What is on the user, that a patient or a guest that just wanders in? What needed to be in their device to make this work in that healthcare?
So this is in US, and obviously we've got the benefit of the US MNOs have been deployed Passpoint, so it leverages the MNO profiles, and I think that's key. It's about access networks, but it also is about credential providers, and so we benefit from the fact that this is a US healthcare provider, and we benefit from those US Passpoint profiles. So that's primarily what we needed.
Okay, one final question.
How do you get the location information within the building to generate those maps? Especially, do you have some 3D maps as well to
3D maps? So if you there's a link, and I think we'll share the presentations. I think Thiago, but the link is to GitHub, which allows you to create your own maps. So everything is there, and obviously you can source that information, then display that on whatever mapping tools that you have.
Yeah, and by the way, all the presentations will be shared once the event is over the next days.
Okay.
Okay, Mark, thank you. Great presentation.